So, in this video we're going to talk about the polar coordinate system versus the Cartesian coordinate system, and then we're going to look at how to convert back and forth from one system to another. Okay. Now, the main point here is that really both systems can be used to reference or describe the location of the same point. It just depends on what motions do you want to use. Okay, so when you look at the Cartesian coordinate system, that's essentially a grid system. And when you're given a point, it's an XY point, and we know then the X is the horizontal movement from the origin, and the Y is the vertical movement from the origin. Now the polar coordinates, you're given a point, it's the radius and then the angle, the rotation. And again, all motion is from the origin and 0 degrees, but first you rotate and then you move out a certain radius in that direction of theta. So essentially, what's happening is you have two different systems. In one system, if you want to reference a point, you move over, let's say horizontal and then up. In this system, you rotate out first, so you might rotate and then you go out a certain distance. Right? But you really can reference the same point two different ways. So let's take a look at an example. Let's say we look at the familiar. Start with an XY where you're more familiar with that. And let's say I tell you to go out 4 in the horizontal and 3 in the vertical. So you're over here, right? And this is the point, over 4. Up 3. That's the Cartesian XY. Right? But really, because we know trigonometry, right, we know that we could also look at that as, well, I rotated a certain angle, right? And then, here I dropped my perpendicular, right? So this is my reference angle, theta. And I can say I rotate out, and then I go out a certain distance in that direction. So that would be r. And so in that case, we'd have r theta. All right. So let's take a look then, if we have here for 3, what happens? Well, if I want to find r, I can just use the Pythagorean theorem, right? I can say, well, I know that r squared is equal to x squared plus y squared. So now if I just want to find r, I take the square root of both sides, right? So r is technically plus or minus the square root of x squared plus y squared. But you can tell, so r is always going to be positive. So it's the square root of x squared plus y squared. And if I want to know theta, since I know y and x, and that's what I'm given, I can use tangent. So I can say the tangent of an angle, theta, is the y over the x. And so then when I take the inverse tangent of both sides, right, then theta is the inverse tangent of the ratio y over x. Now, we'll see when we do some examples, because of the theoretical restrictions of inverse tangent, right, we can only find your angle from negative pi over 2 to pi over 2. You have to compensate a little, but it's not a difficult thing to do. This actually gives you the information you need, right? And really, if we look at it the other way, let's go ahead and figure this out for this right here. So let's go ahead and say if we had been given here, r is the, let's actually do this. So in our case, r is the square root of 4 squared plus 3 squared. So we have 16 and 9 is 25, square root of 25 is 5, so r is 5, right? And then here theta is inverse tangent of, let's see, 3 over 4, right? And when you put that in your calculator, you're going to get 36.9 degrees. So we're going to say about 37 degrees. Right? Now, if you were instead given this information, and we said here's a triangle, and I'm telling you that this is 37 degrees or 36.9 degrees, right? And it's accurate, like that's in standard position, and then that r is 5, how would I find x? And how would I find y? Well, your knowledge of trigonometry. You know that x is the adjacent side, right? is also the adjacent. Y is the opposite. Or of course you could use x over r, y over r. You can use adjacent over hypotenuse, opposite over hypotenuse. But essentially you'd say, well, okay, the cosine of 37 degrees is x over r. In our case, we know r is 5, so let's go ahead and fill that in. So x is 5 cosine 37 degrees. And we could do the same thing for y. We could say sine of 37 degrees is y over 5. So y is 5 sine of 37 degrees. So essentially what we just found was that x is r cosine theta and y is r sine theta. Okay? But you really don't have to memorize this if you just essentially realize that you've got 4 different variables here. You've got theta and r for one system, that's the polar system. You've got x and y for the Cartesian system. You're really just looking at a triangle and put everything together. What you'll get is, when you're converting from Cartesian to polar, right, you're given x, y, so you need to find the radius and theta. So r is the square root of x squared plus y squared. Theta is the inverse tangent of y over x, and we'll see how to compensate. And when you're converting from polar to Cartesian, you go the other way. You're given r and theta. To find x and y, x is just r cosine theta, y is r sine theta. That's it. All right. So let's take a look at some examples then. Let's say we're going to convert from polar to Cartesian. So we're given r and theta. And oh, I think I set these up so that, well, we'll do A, B, C, D in a little later. All right, so on these then, what I'm going to do is just set up, let's see here, for E, if I want to know x, all I have to do is do r cosine theta, y, r sine theta. So here we're going to do x equals r cosine theta, y equals r sine theta. All right? So for E, we're going to do x is, let's see, 7 cosine of negative 15 degrees. Y is 7 sine of negative 15 degrees. And if you do that, what you'll get is 6.76 here and then negative 1.81. Now what you might want to do is a quick little check and say, okay, does this make sense? If I'm out here at 0 degrees and I rotate into the negative 15, so in this direction, right? And then I go out 7, I'm going to be somewhere in here. Does that seem about right? I go over almost 7 and then down 1.81. Yep, looks good. The two systems seem to be working. So let's try F. So x equals negative 5 cosine of 35 degrees. Y equals negative 5 sine of 35 degrees. Let's go ahead and find those out. So it's negative 4.10 and negative 2.87. So let's take a look if that makes sense. Here we're saying we're going 35 degrees, something like in that direction, but we're going negative, so we're going to actually go this way. So our point should be somewhere in here. Is it? We go negative and negative. Yep, that's about right. G, we have x is 12 cosine of 60. Y is 12 sine of 60. So here what you would get, but be sure you're in degree mode when you put these in your calculator. You'll get 6. And here you'll get 10.39. So again, let's check that out, see if it makes sense. In this one, we're rotating out to 60 degrees, somewhere like in here. And we're going way out here at 12 somewhere. So does that make sense? We went over 6 and up 10. It's 10.39. Yep, that looks good. Last one for this, we're going to have x equals negative, let's see, 8 cosine of negative 70 degrees. Y equals negative 8 sine of negative 70 degrees. And when you put that in your calculator, you get negative 2.74 and 7.52. All right. So let's take a look if that makes sense. Here you're rotating out negative 70 degrees, somewhere out in here in this direction. But you have to go out negative, so you're out really up here somewhere. And see, does that seem to make sense? You go over a little bit in the negative 2.74 and up 7.52. Looks good. Okay. So I usually do a little visual check because, you know, it's easy to make a mistake. Let's look at going the other way. So here we went from polar to Cartesian. Now let's look at going from Cartesian to polar. And here you have a restriction here on theta. You're being asked to always express theta from negative 180 degrees to 180 degrees. So, but a lot of books do that. I don't require it, but we're going to go ahead and follow it so you can follow the book. All right, so here we're given an x, y, and we got to go to r theta. Now in that case, remember, we're going from, let's see here, Cartesian to polar, so we're going to use the Pythagorean theorem and then the inverse tangent. All right, so let's take a look at A. So here we're going to say that we're going to have here r is equal to the square root of 7 squared plus 5 squared, right? And that'll give us 8.6 for the radius. And then theta is inverse tangent of y over x, right? Which is going to be inverse tangent of 5 over 7. And you'll get about 35.5 degrees. So let's see if this makes sense. So we know in this one we'd be in quadrant 1 over 7 up 5, and let's see if this makes sense. We would rotate 35.5 degrees and go out 8.6. So that's about right. We'd be somewhere in here. Okay. Let's look at B. Is negative 4, 1.2. And again, this is an xy coordinate. Oh, and by the way, 35.5 was in this interval, so we were fine there. All right. So here we're going to say r is equal to the square root of x squared plus y squared, so negative 4 squared plus 1.2 squared. Right? And so we're going to get here 4.2. And then theta is the inverse tangent of y over x. So we're going to have 1.2 over negative 4. Now remember, this is a negative ratio, and if you recall, inverse tangent, you're only allowed to find an angle somewhere from negative pi over 2 to pi over 2, right? Somewhere in here. So we expect our answer to be negative rotation, and of course it'll be in this quadrant 4. So let's see, when you put that in your calculator, you're going to get negative 16.7 degrees, right? And let's see if that makes sense. What we're being told is we're going to rotate in the negative 16.7 degrees, and then we're going to go out 4.2, and let's see if that makes sense. Let's see here, we would be at negative 4 at 1.2. So you're like, wait a second, I know I'm supposed to be over here. So you're like, well, wait a second, that can't be really the angle I should be using. So now what do? You compensate. This is where you compensate. So where I set up here, compensate, that's what I mean. So the idea here is that when I drop the perpendicular, I know that this reference angle theta is 16.7 degrees. Now it's negative, but the reference angle itself, remember, is always positive. So that's 16.7 degrees, which means that this over here is also what? 16.7 degrees, right? And I'm trying to express this as an angle somewhere between negative 180 and positive 180. So what I really want to say is I start at 0 and I rotate this much. So how much is this much? Well, it's 180 minus 16.7, right? So if you take 180 degrees minus 16.7 degrees, you'll get 163.3 degrees, right? So your r theta that you should be writing would be 4.2, 163.3 degrees. Okay? All right, let's take a look at C. So what I'm going to do here is, you have this here, pause the video and go ahead and try C and D and see what you get. I'll go ahead and follow through on those. So for C, let me make this a little cleaner. We're given 3, negative 6. Okay. So again, for the radius, we're going to say square root of x squared plus y squared, so 3 squared plus negative 6 squared. And when you do that, you're going to get 6.7. And now we're going to find theta is the inverse tangent of y over x, so that's negative 6 over 3. And again, remember, theoretically, the calculator is only allowed to give us an angle between, right, negative pi over 2 and pi over 2, so it's going to give us a negative angle somewhere in here. And it gives us negative 63.4 degrees. Right? Now, let's take a look and see what's going on here. So we're told we rotate negative 63.4 degrees, so something like this, right? And then we go out 6.7, which would put us somewhere, I don't know, here, right? Does that look like what we have here, going over 3 and down 6? Yes, it does. So what I'm going to say then is, and this angle is here in this interval, right? It doesn't exceed negative 180 going that way. It's not less than a negative 180. So r theta will be 6.7, negative 63.4 degrees. Okay. And then the last one, D, was negative 12, negative 5. All right, so again, with the radius, we're going to do the Pythagorean theorem. So negative 12 squared plus negative 5 squared, and you'll get 13. And now theta is the inverse tangent of negative 5 over negative 12. So you'll get 22.6 degrees. Now let's check this. According to this, we're being told, okay, you're going to be somewhere, go out 22 degrees, you rotate 22 degrees somewhere in this direction, go out 13, so you're on somewhere way out here. Does that seem to match what you have here? Well, what I have here is negative, negative. I should be out here, right? So what has to happen? I have to compensate again, right? So let me get a different color. So what we see is the reference angle here is 22.6 degrees, but that means that this is also 22.6 degrees. And what I want to do is provide an angle somewhere between negative 180 and positive 180. Well, if I try to do the positive, I'm going to have to do 180 plus 22.6. That's going to exceed it. Not that that's actually wrong. It's just this particular, oftentimes books put on this restriction. Could you really say 180 plus 22.6? Sure. Now, but because we want to have this theoretical restriction, we're going to go in this direction. Starting at 0, we're going to go out this way. So the way we're going to reference this angle is to go that way. So how do I say this? Well, this would, if I went all the way here, I'd be at negative 180. So I want to go negative 180 and then plus 22.6. So if you look at that difference, instead of doing it, we could say negative 180 plus 22.6, right? And that's going to give us negative 157.4 degrees. Right? So when you write r theta, you're going to write 13 and then negative 157.4 degrees. Okay. Thanks so much for listening.